All right, so now let's look at trusses. Trusses and frames. When you say trusses, they are structures which are made up of joints and members. Joints and members. Don't forget joints and members. And we will look at what members are and what joints are. So in the members, there are forces in there. If the force in a member of of a truss is a tensile force, then that member is said to be in tension or a tie member. Tension is a tie member. Yes. So you can say some members are in tie. Some members are in tie. I'm coming. So that's what do you call it? So members are in tie. And if the members are also having uh, compressive forces, that the forces are compressive, that is the forces are towards the joint, then when they are compressive, so that's compression, we talk about it as a strut member. Then a member is called a strut. So before you tackle the trusses, you need to know how to find something we call reaction forces. Reaction forces, they are the forces at a reaction, or they are the forces at a surface. So for instance, you can see a reaction here like this. This reaction, we normally see it a lot in this sport. It's called the pin joint. The pin joint. The pin joint reaction is made up of two forces, one in the x direction, one in the y direction. And in the x direction can either go to the left or can go to the right. So you can also have a pin joint like this with a reaction going to the right and a reaction going to the down. So it depends on the forces that we are looking at so that the system will be balanced. You understand all these ones, so whether the force will go to the left or to go to the right or to go up or to go down. But what you should know is a pin joint is made up of two reaction forces. Then we have what we call the rulers. The rulers. The rulers. The rulers is only having one reaction force, which is the y component. It has only y component reaction force. It doesn't have s component reaction force. Alright, so now let me just screen here and let's start with this problem. So in this problem, we are going to use the method of joints. We have two methods of solving trusses. So we are going to use the method of joints, which is a little bit simpler, but you work a lot. We look at the method of section and the model. That one is a little bit simplex. That is a simple and a complex altogether, but it will be fast. So using that method will be fast. So it depends on the method that the industry or the company wants to finish the work. The company wants to develop a trust system using a shorter period of time, then they can do the analysis with a with section method of section. If they want to take much time, then they will use method of joints, and you should get the same answers. I mean, the same forces, the same members, everything should be right. All right, so now let's solve this. If you want to solve this, you need to know the reaction forces, as I said. So I will draw my what? I will draw my free body diagram as we know. This one is very small. Let me even use black. I like changing color so that you can just know what's going on. So here is 8 kilonewton. So this C here, you can see it's a ruler. It has only one component. And here it's a pin joint. So I have two components. So I have two components. So This one I brought it down because this is up and this is already down, so it doesn't say anything. So now let's see here. Here there is a 5 kN here. So here will be AY, the Y component. Here will be AX, the X component. Then here too will be CY, the Y component, because ruler has only one reaction, which is in the Y direction. Alright, so now let's calculate the angles. Here is 90 as you know. What will be the angle here? So here is 3 meters, here is 4 meters, here is 1 meter. So if the opposite is 1 meter, the adjacent is 1 meter, the angle is what? 45. Because we are at 45 is 1. So it means the opposite and the adjacent should be the same. Alright. Then here we don't know. So we need to find the angle here. How can you find that? You can use opposite and adjacent. So tan theta is opposite over adjacent, and theta will be tan inverse of 1.33. So I will quickly watch that tan inverse of 1.33. What will I get? Sorry, it's 53.06. 53.06. Or better still, you can use the idea of triangle. So you know that here is 3, here is 4. So if you want cos theta, you just find this hypotenuse, which will be 5, because this is from a 4, 5, 3 triangle. So the hypotenuse will be 5. So if you know the hypotenuse as 5, then if you want cos theta, which is as a result of this part, adjacent over hypotenuse. Then sin theta, which is here because of opposite, it is 4 on 5. Then if you want tangent is also 4 over 3. So now you can use this angle 53.06, or you can be using this fraction, because if you find cos theta, which is cos 53.06, you should get the 3 over 5. If you find sin 53.06, it is 4 over 5. So it doesn't change anything. So you know that here it will be 5 meters, because it's a 5, 4, 3 triangle. Alright, so now let's start. Let's calculate the reactions. So I will go like the summation, or I need to even, yes, so let me say take moment about point A. And if you take moment, it should be 0, because you are dealing with what? Statics, basic mechanics, statics. So statics, summation of forces in the x component is 0, summation of forces in the y direction is 0, summation of moment is also 0. So we don't want the body to move, everything should be at rest. So the summation of moment at A. So this is A. And you can see that at A, reaction AX and AY is passing through A. So they will not cause a moment. I mean, AX and AY will not cause a moment, because they are passing through where we are taking. Here is of course A, here is B, here is C, here is D, because they are passing through where we are taking the moment. The line of action is passing through that joint. So taking moment about A, 5 kN will take a moment. So how will it do that? So you put your finger here, at where I've placed the black dots at A. Put your finger there. Look at how the 5 kN will cause a moment on you. Look at how it will cause a moment on you. So you can say the 5 kN will cause a moment clockwise, through the point A. It will cause a moment like this. So if you take the 5 kN, it will rotate you clockwise, which is negative. Clockwise is negative. Then you check. You said moment, if the force is horizontal, the distance should be what? Should be vertical. So this is the 5 kN. So what will be the vertical distance? It's what? 4. You can see that 4 meters. You are taking the moment here, so it will be 5 times 4. 5 times 4. So now it will be 5 because negative 5 times 4, because it's negative because it was clockwise. What force will cause a moment again? The 8 kilonewtons at B. So now I want you to put your finger at where you are taking a moment A. You can see that the 8 kilonewtons will take you clockwise. Will take you clockwise at A. So it will be minus 8 times what will be the force is vertical, so the distance will be horizontal, which is what? 3 meters. 3 meters. So 3. Then is that all? No. See why? This one here also cause a moment. But this time, if you put your finger at where you are taking the moment, you see CY will take you up in the anti-clockwise direction like this. So it will rotate you at A in a positive direction, which is anti-clockwise. Positive direction. So it will be positive, so plus CY. The forces are vertical, so the distance will be horizontal. 3 plus what? 1, because you're taking the moment from B. So 3 plus 1. 4, and this is equals to 0. So you can find CY from this. So 4 CY is equals to 20 plus what? 24. CY is 44 over 4, and that's 11 kilonewtons. So I found CY. So I can remove CY here, then put what? 11 kilonewton. 11 kilonewton. Then what again can I find? Then I come and use the assumption. So I will say summation of forces in the Y is what? 0. 0. I've told you statics, we are dealing with this moment, forces in X, forces in Y. All these ones are equal to what? Big 0. So don't forget. So let's sum the forces in the Y component. At A, how many forces are there? 2. And AY is in the Y component. It's going down, so negative AY. Then you come to B, minus 8, going down. You come to C, sorry. You come to C, cancel. You come to C. C is going up to plus 11, and this is equal to 0. So if you want AY will be equal to 11 minus what? 8. 3 kilonewton, right? 3 kilonewton. Then you come to summation of forces in the X. So that one too, if you are A, negative AX, because AX is going to the left. Left is negative, negative X. So negative AX. You come to B, there is no horizontal force there. You come to C, no. You come to D, yes. So D is going to the right, so plus 5 equals to 0. So AX will be equal to 5 kilonewton. Neatly done. Neatly done. Yes, the word is neatly. Neatly presented. That's the word. The word is neatly presented. So now we'll go again. So now that we know all the forces, we can place them there instead of AY, AX, and those things. So I'll bring here. What did I get for AY? I had 3. Then AX, I had 5. So you take joint by joint because you're using the method of joint. So joint by joint. So let's start with joint A. You take every joint. But someone is asking, hey, doc, so what is a joint? So a joint is where 2 or more members are reaching or passing through. 2 or more members. 2 or more members. So you can see that here we have a member here, AD. We have another member here, what? AB. AB. Here, AB. These two are not members. These forces, they are just reaction on it. They are not members. So a joint is made up of 2 or more members. AD is a member, AB is a member at A. When you come to B2, AB is still a member, BD is now a member, BC is now a member. This force down here is not a member, it's just a force on the joint. Take note. So now you take a joint, you bring all the reaction forces on it. So here is 5 kilonewton, then here is what? 3 kilonewton. This is going to the left, so we Wish this will go to the what? The right. So that's what AB. Force in remember AB here. Here. AB is here. Can see that, right? Then lastly, AD. So you can see 3 kilo going down. So it means forcing AD will wish to come up, so that we are doing this because we will attain a static truss. You are moving on a bridge and the truss system is moving. To cause an accident, right? So we want it to be stable. So it means if we have a force going to the left, the next force should go to the right. If we have a force going to the up, the next force should go down. So 3 kilo down, here will be what? A. So now let's find the forces of it. So summation of forces in x is 0. So what can we say? We can say minus 5 plus 8 is equal to 0. AB will also be equal to what? 5 kilonewton. This one can even see it by inspection, right? Then summation of forces in y is also equals to 0. So you will see that we get minus 3 plus AD is equals to 0, and AD will be equal to 3 kilonewton. 3 kilonewton. Now that you have gotten these, we move on to joint what? Joint B. So here is joint A. We move to joint B. Joint B. We do the same. So joint B, take, here is joint B. Take it. So we take it here. We are now engineers. So joint B, we have this 8, which is not already, which is not a member by a force. Then what members are they? A, B. So this is where the argument is, and this is where you need to understand, right? So I'm taking my time. Just follow me. So you see that at joint A, AB moved to the right. AB moved to the right. You can see that, right? So if we say AB should go to the right at B2, joint B2, it means our joint is moving, or the whole truss system is moving to the right, for which we don't want. The truss should remain stationary. So if AB joint is moving to the right, then when we come to B joint, AB should move to the left. Yes. So this AB that we had what? We had 5 kilonewton. It will now be to the left on joint B. Can you see that? Yes. So our now the joint is not moving again. Then new let's see the new members. So now the new members that we are bringing on board, our new colleagues that we are bringing on board is this member here, this member here. And I chose going up, not down, because this is going left. We will need, this is made up of two components, right? Yeah, so we need the component to go right and the y component to go up, because this is coming down 8 kilonewtons. Then what new member do we have again? We have this new member, BC. Can you see that? Yes, BC. And BC too, we can say let BC go to the right, because 5 kilonewtons is going to the left of it. So now we will need the angle here, which I said we can use 53.06. You can use the fraction. I will go with the fractions, right? Yes, we've been using the angles too much. So I'll go with the fraction. So now let's do the force analysis, right? So here is this. Let's do the force analysis. So what will I do? I will find the summation of forces in the x. So it will be minus 5. So this one, if we should resolve it, we get what's the force there? Remember there is b. So we get bb cos theta, then here will be bb sin what? Sin theta. We know this already. So minus 5 going to the left plus what? Bc. Then if you have a force resultant like this, the x component will go to the right, the y component will go to the will go down, will go down. So x is going to the right, y component is going down. So I get bc to the right cos theta. But I know what cos theta is. Cos theta is 3/5 here from the 5 4 3 triangle is 3 over 5. So let me print cos theta and put 3 over 5 there. Can you see that? Yes. Is that all the S component that we have? No. Then plus BD. So this one should be, no, plus BC, sorry. Plus BC. Plus BC. So plus BC. Then this one is BD rather. You see? Yes, BD cos theta. So now let's simplify this. So it will be 3 over 5, and this is equal to 0 because we know summation of f x is 0. So 3 over 5 BD plus BC is equals to what? Is equals to 5. Equation 1. I append page to solve more questions, right? Yes. So now let's continue. Let's continue. So now I have this. Then I will do summation of forces in the what? In the y, which is also equals to 0. And what will I get? I will get in the y. So I will get positive BD sin theta, which is coming from the component of BD at an angle of theta there. You can see that it's coming from that component. So BD sin theta, then minus 8. 8 is going down. So minus 8. And this is all equals to 0. So if I have this, it's the same as BD. What did I say sin theta is? If you check the triangle 5 4 3, sin theta will be 4 over 5. It's yes, 4 over 5. So times 4 over 5 minus 8 is equal to 0. So it means that finally I will get 4 over 5 BD is equal to 8. Equation what? Equation 2. Then if you have this equation, you can find BD. So from 2, BD will be equal to BD will be equal to 8 divided by 4 on 5, which is 40 on what? 4. And that's 10 kilonewtons. Then if you know BD, you can say from equation 1, BC will be equal to 5 minus 3 on 5 BD. So I'll get 5 BC to be 5 minus 3 over 5. BD we had 10. 5 goes here, 1 goes here, 2. So 6. Then I'll get uh, minus 1 kilonewton. Minus 1 kilonewton. So that's what we get for. That's what we get for what do you call it? BC, right? That's what you get for BC. So now what am I going to do? What am I going to do? So what I'm going to do is this problem, whatever you do is when you assign a direction to a force, then after solving, then you see the force is having a negative answer. You see, force is a vector quantity. So if you get a negative force, but you represented it with a with a right direction, then you had a negative answer. It means the correct direction should go to opposite with what you chose at first. Should go to opposite with what you chose at first. So that's what it means. So you see, we had negative 1 kilometer for BC, right? Where is BC? Here is BC. Here is BC. And BC, I I made it I made it go to the right. Yes, I made it go to the right, and we had that. So what it means is that, all right. So let me see. So coming down, coming down. So it should be BD cos theta minus BD cos theta. Where is it? Minus BD cos theta. Here. Here is what I'm talking about. Here, I didn't do the reduction. We should go to the left instead. That's what I mean. It should only be BD cos theta. Then I will raise this. So it means for the with my FS, it will be minus 5 plus BD cos theta. Cos theta, is this still, yes, it's still 3 over 5. Plus BC, right? Yes, so nothing even changes. It's fine. Then, so BD I had 10, so I put the 10 there. So minus 1 kilonewton. All right. So if you assign the right direction, then get a negative. What it means is it's rather in compression. It's rather in compression. So you don't you don't panic, right? You don't panic. Yes, you don't panic at all. So you don't panic at all. All right. So now let's move on. Let's move on to joint what? What joint are we at? Joint C. Joint C. So from joint C, I'll change it to black again. Joint C. Here it is. So joint C, I have a reaction force there already, which is CY 11 kilonewtons. Then let's see the new members coming. So the new member I will write first is the CD. CD member, this one. CD. I see the CD coming here. CD. I'm not putting any arrow on it yet. Then I have BC, which is coming from joint B. This is joint B, right? I have BC. BC went to the right here. It went to the right here. So it means that what it means is that it should go to the left when you go to joint C. If that's not the case, it means that our joint will be moving. That's what it means. If you don't do it in that manner, it means our joint will be moving. So here, that's why I told you, this course and every course you take serious, it will make you sharp. So here, my BD for today is going to the left. That's why I had the negative. And the actual sense, I should have gotten positive. So let's do it again. 3 over 5 plus BC. It will be minus BC. 3 over 5 minus BC. So here will be minus. Then I'll put minus here, minus BC. Okay, yes, because left, then BC was positive. So left, positive for 0. So now this is what I should get. Then if that is the case, then BC would actually be 3 over 5 BD minus 5 rather. So 3 over 5 BD minus 5. Then I'll clean this. So it will be 3 over 5 BD I had 10 minus 5, which is 6. 1, 2 minus 5. Yes, so I don't understand should be in comparison, right? Yes, should go in this way now. 1 kilo. So here is 1 kilometer. So it went to the right on joint B. So it comes to joint C, it should move to the left. If it goes to the right, it means joint C will move further away, which will make the truss system move towards the side. So it will come to the left. Come to the left. And you know the value there. This right is 1 kilometer. 1 kilometer. So now what again? Yeah, that's all. So now we choose the direction of CD. CD, how CD should move, whether away from the joint or towards the joint. So you see BC is going to the left. So if we should make BC move away from the joint. It means CD will have a component of this left again, then go up, which you don't want because BC is going to the left, then the component of CD to go to the left. If you choose the direction of CD moving away from the joint, right? Can you see that? Yes, CD has the X component moving to the left. And look, we have already 11 kilonewton going up. So if we should choose CD moving like this, it means the Y component of CD2 will move up. And our system will be moving up and to the left. We don't want. So what we will do is we will not choose the direction that I chose. Don't choose that. We will not choose that, but rather we choose towards the joint because you know that if CD is towards the joint, this will be the component, right? The component will go like this. So the S component will move to the right and the BC will take it to the left and it's balanced. The C DY component will move up down, then the 11 kilonewton will move it up and it is balanced. Can you see that? Yes. And that's what you want. You want a stable system. I need to develop a network, right? All right, so now I have this moving to the right, this moving to the left. So we've spoken about this one since the revolution. So now summation of forces in X equals 0. So now let's sum the forces in X. I'll get minus BC plus, yeah, so we should know the angle leaving here. It's 45, right? 45. So 45. That one too, you can deal with it. Can deal with it, right? Because you know that here is a 4 triangle with the hypotenuse not known. So you can find the hypotenuse, or you can still go with the 45. It's fine. 45 is okay, rather than 53.06. So now let's go with the 45 now. Alright, so negative BC plus CD, yes, CD will move to the right. The CDS component. So CD cos 45 degrees, and this is equals to what? 0. Equals 0. But I know BC, so CD cos 45 is equals to BC. What is BC? BC is 1 kilonewton. So this implies that CD will be equals to 1 over cos 45, which will make CD to be equals to cos 45 is root 2 on 2. So it will be 2 on root 2 kilonewton. 2 on root 2 kilonewton. All right. Then I write it in decimal, I can write it in set. Now let's move on to sigma Fy equals 0. Summation of force in the Y. No force in the Y. So that one, I'll get a positive 11 kilonewton from Cy going up. Then minus the CDY component is going down. So CD sine 45 equals to 0. Then CD will be equals to 11 over sine what? 45. Which is also 22 or root 2 kilonewton. So this is the same as 15.56 kilonewton. Yes. And this one, the yes. So this one, you can either use any of them to find. So I found it using this. So what it means is if we should find 2 over root 2, 2 over root 2, then we'll be getting, so you can use any of them to find. Basically, that's what I mean. You can use any of them to find. All right. So that is how we go about this one. That's how we go about that one. All right. So Basically, that is it. So now we ask ourselves, have we found everything? Yes, we found everything. So we found, so you put the values here: A, B, B, C, C, D, A, D. A, D is what we did first. And what did we get for A, D? A, D was the same as, let's come to 28. A, D was the same as 3 kilometers. So 3, B, C, B, C is here, it's here. And that will be found as joint B. B, C, joint B. B, C, we had 1 kilometer. C, D, what I just found, 15.56. 15.56. Uh, Kilometer. Then we also have the what? BD and AD. BD. Where is BD? BD, BD. BD is up there. So I'm finding it from joint what? I'm finding it from joint B. So BD we had 10. 10. Yeah, it is 10. 10 kilometers. Now what's AD? AD. So AD is rather than 3 kilometers. Then AB is that one 2 points. So AB is the 5 rather. And that's all. So if it's pulling away, it's a tension. So for instance, AB is a tension, BC is a tension. What again? BD is also pulling away, it's a tension. It's only CD which is a tension, compression. CD, because that was the joint and CD moved towards it. So CD is a compression. But aside that, let me see, BC is tension, AB AB is also tension, BD is also tension, and AD is also tension. All right, so that's the end of this particular question. We shall meet again. Bye for now.